What you and the Versus team have been working on over the past year is to try to show the world that there is an alternate solution that is much more efficient, right, to make good agents.
The past year has been focusing on two fundamental ways of creating intelligent agents, making them smart and cheap and efficient and thereby sustainable. Start off with an informed world model, generative model, that is principled and incorporates all your prior beliefs about what this agent should do.
How do you incorporate beliefs?
You first of all take the semantic beliefs and then you read that formally or mathematically as a Bayesian belief, which means it's now a conditional probability distribution. So immediately when you're talking about sort of agents with beliefs that can make decisions under uncertainty, you are now talking about the encoding, the representation, the communication of belief structures or probability distributions. You achieve that by being Bayes optimal. Bayesian decision theory, so it's the kind that people, financial decisions or even decisions about who to date or what to eat, which restaurant to go to, all have this kind of Bayes optimality. So you've got a specification of the kind of outcomes that you would anticipate given the kind of thing you are. If you're a financier, you might want to be very rich. If you have a particular predilection for certain foods, you would choose this kind of, and you would be surprised otherwise. So you write down an objective function that basically takes the average reward or cost or violation of your constraint.
Your background in neuroscience, understanding how rewards operate in decision-making system, interact with uncertainty. And this is what you've been able to model and to put in the product, right? In every conversation on AI this year in Davos is the environmental impact of LLMs, the fact that they require a lot of compute, they require a lot of energy, and they have a lot of, negative environmental impact. You guys have a breakthrough where what you're able to achieve by augmenting the performance and having optimal agents, you can achieve it with less processing, right?
Absolutely. And that's one of the cornerstones of this ambition, to sort of socialize this kind of approach to intelligence. That efficiency you're talking about comes hand in hand with this kind of Bayes optimality. We're just applying the principle of least action, where action is energy times time. Not just making the right decisions, but also getting the right data to resolve uncertainty given your current beliefs. So there's an epistemic aspect of being Bayes optimal as well. And that's also thermodynamically the most efficient way of doing it. From the point of view of sustainability, what you save in terms of being informationally optimal means that you are doing it in the most sustainable way from the point of view of energy expenditure. It costs a certain amount of energy and money to change your mind, technically to change information that is encoded in a machine or in your head. That means there is, in principle, the most efficient way of doing it. That is the principle that we want to apply, and we want to write that down in software. Beyond that, we want to socialize that idea as the right way forward, that by definition is sustainable in the sense that it doesn't burn through inefficiently too much money and too much electricity. This is a very simple little world that you have control over. So now, to play properly, you are being an agent in a very well-defined, very simple little world. So it is the minimum kind of space sandbox in which you can explore agency. And the question is, what's the most efficient way of learning to play, to be an agent in this very, very simple world? One of the key benchmarks about the efficiency with which you do it, the amount of the dollars that you'd have to pay in order to get to an endpoint of proficient or expert performance, is the number of exposures you need.
The number of repetition.
What we were aiming for was at least an order of magnitude or a 10x or possibly 100 times more efficient learning to be an agent in this very simple, well-documented kind of world. There are two ways that you can sort of tackle this. The first one is to build a bespoke world model under which you can then apply this principle of least action, this principle of least effort, maximum efficiency. And that's what's been showcased recently in terms of press releases from Verses, that by applying the right kind of generative model that is as simple and efficient as possible, and also using exactly the right kind of belief updating, Bayesian belief updating encoded in the software, then you can achieve that ambition of showing you can do this 10 times more efficiently.
What are the concrete applications that Verses is going to offer to its partners, its clients, based on this improvement from what we talked about 12 months ago?
If this is the right way to do it, and by right I mean this path of least effort and least action, then everybody should be doing that. They should be enabled to apply these principles to their problem space. One has to enable, one has to socialize. What's the best way to do that? Well, I think in the first instance, just to provide people with the infrastructure, the right kind of software, the right kind of accessibility in terms of skilling them. Well, part of this efficiency is that it's really easy to build these models and apply them.
Everyone is not only talking about agents, but autonomous agents, which means that these agents are going to be having a form of autonomy in order to make decisions, the right decisions, under uncertainty.
If you're aiming for a particular kind of intelligence, and we are aiming for a natural intelligence that is sustainable and is predicated on a first principle account of intelligent behavior, sentient behavior, active inference, then you would have in mind a very different set of benchmarks than that which have been designed to test deep reinforcement learning or transformer architectures or large language models. It's not good enough just to be Bayes optimal in a Bayesian decision theory setting. You also have to imbue your agent with the principles of optimal Bayesian design. You have to enable it as an agent.
Well, give agency to the model in order to be able to have a form of autonomy.
Of an epistemic sort, smart data gathering. So if you've designed one of these truly intelligent agents, it will know what kind of data is best suited to resolve its uncertainty, given it has beliefs. That is what is lacking in current, say, large language models. Not my student, but certainly Ellen Maguire's student, Demis Hassabis. I've heard him recently say this is exactly what he's experiencing. Demis started off by wanting to be biomimetically inspired. He brought with Eleanor to the table things like scene construction, understanding how we make sense of the world and how we navigate agentially through that world. But now what he says, we've lost sight of the neuroscience and the basic research. It's all engineering. I think that's a danger. Talking about socializing the right way of doing things, I think will bring people back to the fundamentals.
Into science and technology and not just tech.
Yeah. How Verses does that is basically by putting a little university inside a company.
Congratulations to you and Verses on the huge progress. Looking forward to our next conversation and enjoy Davos.